Good morning, tubers. Welcome once again to the Stink Bug Works, the super secret research and development division of Dr. Jet Laboratories, where you get subjected to yet another unedited, unscripted stream of consciousness video with my water heater going off from time to time. So be it. Anyway, I was going to wait until I had the fixtures for the setup board, but I thought I'd let you in since I did make the plans for the slab-sided version of my 10-inch challenge public. I thought I'd go over the construction because the plans have no notes in it. It's 1/64 balsa sides, bottom, and top with 3/32 square balsa longerons and stiffeners in here. So everything in here is 3/32 balsa. This is all 16th balsa. The sponsons are the lightest half-inch balsa you can find, contest grade stuff. This stuff weighs nothing, so the lightest stuff you can find. Motor mount and turn fin attachment are 16th plywood. I'm going to make these available laser cut, but this is real easy to do with a belt sander. You make them in no time at all. Ride pads, I'm using 1/32 carbon fiber sheets. You could use 1/32 plywood, and just seal it up. For sealing, I'm just using spray lacquer, Home Depot spray lacquer. Although for my canopy cover, since the bubble is plastic, I used enamel. Let's talk about this canopy cover for a minute. You got to have a bubble to clear the motor, so you can make a bubble out of 16th balsa and make a little tent, kind of like they did on the one of the JAE riggers. I think it was the Mini Sprint. You notice I did the grain this way here, and where it goes over the bend, I did the grain that way. Unfortunately, though, this bubble was so long that it went up into the grain going this way, and it creates a stress riser right there. So I reinforced it with some carbon fiber veil and attached it with CA. So for clearing the motor, you can do anything you want. You can make a balsa canopy. I happen to have this little streamlined bubble from some other kit somewhere along the line, so I used it. And so that's it. Again, 16th balsa. Now, let's talk about the rudder. Let's talk about the rudder for a minute. The rudder could be an issue for some of you, and I'll show you why. Let me make this a little easier to manipulate. Okay. Here's why the rudder could be an issue. I was originally planning on using this rudder. You see, I even provided holes for it there. But the rudder's too damn close to the propeller. So the workaround, the real easy workaround is this. That if you were to take, let me make sure I got this in the picture here, a 45-degree block and mount this off at 45 degrees, that would move the rudder out of the way of the propeller, and the control cable could come up through the inside here, like that. What do you guys think as a workaround? Huh? That has potential, and I'd just use a piece of plywood here. In fact, I'd take 1/4-inch ply and epoxy several layers together, and then sheet metal screws into the plywood this way, and then you can actually drill and tap the plywood. So you could go in here and go in here. And so, you know, have a little block. Or I could machine a block out of aluminum, but oh God, the setup time would be forever because I'd have to do something to get the 45-degree angle. But that will get the rudder out of the way of the propeller, and you can use this rudder. Although my plan was to just use this bracket and make something out of carbon fiber here, something thinner and lighter, because I don't need water cooling. I don't need this big thick thing. I want a nice thin sharp knife blade there. So I think that's about everything you need to know at this time, you know, for building your own boat here. It's pretty simple. I made it as simple as I could. Oh, plywood transom here, just so you have something. If you're screwing into it, you got something to bite into. So there you go, boys and girls. Until next time, jet out.